Okay, good morning everyone again. Andrea Ballabeni, working with Marco Bradini, Marketing, and the others. So for those of you who were in ATIS, you know already that we were looking for a tool for project management. Hopefully an open source tool which could be used with the BIM data in a context of digital twin application, possibly using IFC standards, both for entering data and both for visualizing hierarchy of their structured data. And we want to have this tool also to manage a common data environment, which, you know, especially for large projects, a lot of data come from different sources, different subjects. They are using different formats, and we are looking for a tool to unify this large amount of data in a single platform. And again, we are looking for a tool that could deal with the sensor. Why are sensors so important? Marco has already told a little about it, but of course there are many different categorization of the digital models or the digital twins, but I prefer to see it as a continuum, where on the one side you have a simple digital model where you need to input every data manually, and on the other side there is a ideal digital twin, a copy of the reality, which is so close to the reality that all the forces, all the stimuli that can hit this digital model would happen in the reality in the same way. But can we model such a complex model, like a perfect digital model of it? Of course, this would need an enormous, a tremendous effort. So how could we model it? If we model it manually, then it would take so much time probably that when we have finished to model our model, then probably that building is already collapsed. So we are something in between these two worlds, like an ideal digital twin and a digital model. And so we try to automate stuff. One way to automate inputs is using some kind of sensors. And in the future, of course, using large language models so that the data flows come from outside, from all the sources, and structured knowledge, unstructured knowledge can be easily structured with LLM. That's why LLM are so important in this field. We didn't implement them yet, but as I heard, probably you have the forces to do it in the future. And so we decided to use Open Project BIM, as Marco mentioned, because of its features, since it can deal with the geometry and data, both with the IFC classes and IFC hierarchy, and both using a Revit add-on. Then, most importantly, it gives us the possibility of using APIs. APIs for us is what are APIs? APIs means it's an acronym that means application programming interfaces. For application, it's quite hard to understand the graphical user interfaces, like it is easy for us. And so they prefer to talk to each other. Application, they prefer to use a structured language, a simple language. And so if we teach our sensor to speak that language, we are able to make it possible for the sensor to talk with our application. And of course, I mentioned the CDE, the Common Data Environment, is very important for us for connecting our application to different environments like Mattermost, like Project, like SharePoint, like OneDrive, like Nextcloud, GitHub, Jira, and so on, etc. And all those connectors are already there in Open Project BIM. And Open Project BIM is open source, so we can use it freely. We can. There are some add-ons which you need to pay, but since we are an educational organization, they gave us the possibility to use it for free. And so that was kind of amazing in my opinion. So the basically features of Open Project BIM is the IFC important, IFC visualizer. So as I mentioned, there's a Revit add-on, so we can decide whether to use Open Project BIM as a center, as a core application for managing our data, or using Revit if we prefer. We can manage a project life cycle inside from Open Project BIM, and we can manage project phases, which is very important, and setting gates and constraints for all the phases. As I said, common data environment, news, Gantt chart, calendars, and planning, budget management, and etc., etc. And as I mentioned, more important, API. Work packages are the core of this application. Why are the core of this application? Because they can be linked to all the other entities that are inside this application. In a work package, I can set its status, I can set its category, I can assign a work package to a user or a group of users. We will see tomorrow in the role-play game we are doing. We can set who's accountable for that work package. We can add custom fields, we can add custom work packages to it. And we can set the relation type there is between a work package and another. We can say what is following, what needs to be preceding that work package. We can set a work package parent and child. And so, what is the situation today? So, when we were in Athens, the Revit add-on was just in a beta version, and now it has been officially released. Not all the versions of the Revit add-on are available. It's still under development, the version that goes from 2023 to today, but we can still use it for a Revit version from 2017 to 2022. And we have talked about the possibility of acquiring data by sensor, and now that functionality is fully done, 100%. We talked about representing this data in a graphical way, and the sensor that work is okay. It's 90%, so it's fully functional. But I will deal with it a little bit better afterward, since we are improving it for making it easier to use it in a migrated environment. In Athens, we have just one development environment, one test environment, and that was kind of difficult for a lot of people, since our system administrator, they asked us not to publish publicly this test environment, so we could reach the platform just within the university and within IIPLE, and that was kind of messy for a lot of people. And today, beside development and test environment, we have a production environment. Finally, it's published on ET4D.com. And it's publicly available, and finally we can count on it. And it's much easier even for all of the developers we have at the University of Bologna. So the developers can test new features when they are ready. They pass it to the test environment. The project manager managers can check the new features, and when they are okay, they pass it to the production environment. That's a very nice and clean application lifecycle. So, point number one, the Revit integration. Here, if we prefer to work inside of Revit, this is a typical Revit interface. There is just something different. This is the Open Project icon on the top left. That means that the Open Project BIM add-on has been added to Revit. And on the right side, we can see a pane that is typical of Open Project BIM. So it means that we can use Revit for adding new features, for example, new issues, using Open Project BIM inside of Revit. For example, here we are adding an issue link into the BFC representation of it. That goes inside Open Project BIM, but using the interface we have in Revit. And point number two, the sensors. We started setting up Open Project BIM for having a new kind of work package. We call this kind of package measurement. It's a customized new kind of work package. Is down there, measurement. It's very easy. You just go to types of work packages and you add one with the plus sign, and then you simply define the features of this new class. So we model this class for having fields which correspond to our sensor measurement. So as temperature, humidity, pressure, light, and okay, no, it's not working now because we are missing a microphone, gas, and so on. So we created these customized fields, and for each customized field, of course, you can customize it, saying which kind of data that field is hosting. If there's a minimum, if there's a maximum of that field, that kind of data, and of course, you can set some rules to check the input of the user while it's adding it. One thing, when you are adding a new customized field, you take note of, it's important to take note of the ID that is using Open Project BIM, since this ID will be used in the communication between the sensors and the platform. So it means that PM1, it's just the name of the field, but the real identity of the field is the ID itself. So, about bare metal. So, IIPLE provided us, thanks, nice sensors. They are low-cost sensors, but they are effective. So, temperature, pressure, humidity sensor, that is the BME 280. Light and proximity sensor, LTR 559. Analog gas sensor, CO2, NH3, NO2 analog gas sensor, MIC 6814. A dust sensor that is able to measure particulate matter, PM1, PM2.5, PM10. And finally a camera. This is a Sony IMX500AE. All these sensors are then connected to a Raspberry Pi, which is a very small, cheap, low-cost computer, which we have connected to the EPLE Wi-Fi. And then through EPLE Wi-Fi, we are able to get to the internet and then communicating with the Open Project BIM. Since we are operating in a kind of hostile environment, it's a construction site, we 3D printed camera case, camera holder, camera arm. The camera arm was also important to fix the camera heading, the direction of the camera. And on this picture here, you can see the printed sensor with the end of the camera. The sensor, the dust sensor are here. I'm sorry for the picture. So, what about what we have done with the Raspberry Pi? Okay, we have connected the sensor to the Raspberry Pi, and the Raspberry Pi is able to run a very simple computer language that is called Python. And what does this script do? It does a very simple thing. That does basically a loop. And when some conditions are satisfied, then it starts to do something. If it's an expiring day and the time since the last acquisition is more than something, then the acquisition starts. And so if there are just signal coming from, values coming from the sensors, no problem, the acquisition goes straight forward to the API. And instead, if it's an image, then a further processing step is needed. We are using OpenCV, that is an acronym for Open Computer Vision, which analyzes the image, and that is using a mathematical description. It is called OAOD descriptor that is able to recognize some image features. It can be trained to recognize some image features, like for example, a unit. So, as you can see in this picture, sometimes this descriptor fails, of course. There are some better descriptor, probably LLM are doing much better when we left them. But we thought that for us, for a prototype, it was enough. And another condition is that if it's the last acquisition of the day or the last acquisition of the day, we were storing also the image itself, which was attached to the work package that we were acquiring. If anybody is interested in knowing more about the descriptor, there is a hot descriptor here. That is the link. Or otherwise, if you want to download the code of this script, you can download it from GitHub. From there, it's publicly available. What about the sensor dashboard? Okay, so I said we are the 90% of it. Since the dashboard is already fully functional, but at the moment we have a Python script which is collecting data from Open Project BIM database, and then it sends it to a HTML page to render the graphs. That is kind of silly, since Open Project BIM inside itself is using Ruby. So we thought that for distributing purpose, for releasing our graphs, it was much better to produce an Open BIM plugin, and that's the reason why I still need to fix something with the plugin, but in that way to distribute it will be really easy, so we can publicly distribute it. And for anybody who wants to use that kind of graphical representation, just take one piece of this Open Project BIM, this plugin, and put it inside this project, and it's working. After, yes, just link the ID of the sensor with a simple configuration file, where you just to link your data, for example, the date or the light, with the ID of your custom field. What about the issues that we had? So these sensors are quite low cost, so we cannot expect precision that is formidable, but still for a prototype exercise like this one was enough. And we also think that calibrating the sensor before using them would have strongly benefited the accuracy of the measurements, but still the measurements are quite good even now. And about the counting feature, the people counting feature, of course, having a single camera that is trying to count the people, there are several problems. I mean, sometimes the algorithm can fail, sometimes there are occlusion, like in these construction sites, since there are walls, and so we cannot trust that kind of measurement 100%, but still it's working quite fine. And also there are some improvements that we could do on a coding way, because now we are just looping and acquiring data when it's time to acquire. But what we could do is to average all the data we have between a measurement and the following, so that the noise tends to disappear, since one measurement goes a little bit up, another goes a little bit down, and so if you average them, all this random oscillation, they tend to disappear. Okay, if you want to set up the environment at home, I suggest you to use containers like Docker or Kubernetes. But what we have done is to use just a virtual machine on a server, or a VPS on a server, so that we could easily customize access to the code without any problem. So that is the solution that we privilege. What about future implementation of these things? I mean, sensors. Are you allowing us to acquire data in real time, to enrich a digital twin or a digital shadow? But, and of course, if more data are collected, the gap between the reality and the model reality tends to reduce. But what about the geometry? What about all the other data that we reach through LLM? I have tried to do a little experiment with the geometry. And I passed to an artificial intelligence that is trying to recreate from single images. This is not photogrammetry. It's just a model created by this simple, very low definition image. And of course, there are a lot of mistakes in the model, but still can give us a strong idea of what is happening there in real time. And of course, that model could be automatically acquired without human effort. Finally, okay, this is just the movie that has been built collecting all the images in the construction site. So thank you very much, that's all.